Okay, hello. So today I'm going to tell you about some work that I've been doing using the BlueTides simulation to try and understand the host galaxies of redshift 7 quasars. So in the high redshift universe, we observe supermassive black holes with masses of 10 to the 8, even 10 to the 9 solar masses. These are almost as massive as the black holes that we see in the local universe, but they must have formed in less than 1 billion years. So this raises a lot of questions about how these extremely massive systems could have grown so quickly. One way that we can try to understand this intense growth phase is by looking at what kind of galaxies and environments these black holes live in. And in particular, one thing that we can look at is whether the local scaling relations still apply. So at low redshift, we see really tight correlations between the mass of a supermassive black hole and the galaxy that it lives in. So here, for example, we have the black hole bulge mass relation. And if we look at this relation at high redshift, that can help us understand the growth mechanisms of these black holes. But unfortunately, it's not as simple as just going out and measuring the high redshift quasar host galaxies. So they are currently undetectable in the rest frame UV or optical, which is where these local relations are observed. Now, the reason for this is that at high redshift, galaxies are very small compared to the resolution of current telescopes, and the quasars are very bright. So when you look at these objects, all you see is the point source of the quasar. So until the launch of James Webb, which hopefully will help us observe these quasar host galaxies for the first time, we can only observe the hosts in the rest frame far infrared, generally observed with ALMA in the sub-millimeter. But these observations have quite different biases to observations in the rest frame UV or optical. And so we still really do not understand these host galaxies. So what I'm trying to do is use simulations to predict what the galaxies and environments of these quasars are to be, and also make predictions for what we should expect with upcoming observations. So for this, I've been using the BlueTides simulation. So BlueTides is a cosmological hydrodynamical simulation and an extremely large volume. So it's about almost 600 megaparsec on a side. Now, with this extremely large volume and exquisite resolution, BlueTides is extremely computationally expensive and has only been run down to redshift 7. So BlueTides is absolutely fantastic for studying high redshift galaxies, but obviously we're limited to these very high redshifts. So many papers have used BlueTides to explore black holes and quasars in the simulation. So the previous study on black holes was a couple of years ago when the simulation had only reached a redshift of 7.5. And at redshift 7.5, there was a simulation. But by redshift 7, we now have a much larger sample of hundreds of quasars. And so in my work, we can start to now make more statistical analyses of the properties of quasar host galaxies. So to start with, I'll share with you some results that we've found of the galaxy properties of intrinsic quasars. So here I define a quasar as an object where the AGN is brighter than the host galaxy in terms of its intrinsic luminosity. So we're not considering the effects of dust attenuation. And so here I show two plots. So we've got the stellar mass and star formation rate of the host galaxy against AGN luminosity. So the blue are the overall BlueTides sample, so all galaxies. The white points are quasars, and the black are the 10 most massive black holes in the simulation. So what we find is that quasar hosts have a wide range of stellar masses of around 10 to the 9.5 to 10 to the 11 solar masses, and very large star formation rates of 40 to almost 1,000 solar masses per year. Something else that we find that is not shown here is that quasar hosts are also generally bulge dominated. So these three properties are really interesting to understand, but we find that they're actually not particularly different to the overall population of high redshift galaxies. But one thing that is different about quasar host galaxies is their size. So here we have the half mass size against stellar mass of the host galaxy. And what we can see is that quasar host galaxies and the host galaxies of the most massive black holes in the simulation are really compact compared to the average galaxy at redshift 7. And so unfortunately, what this may mean is that it is still going to be really hard to detect quasar host galaxies with upcoming instruments, just because unfortunately, these systems seem to be preferentially located in these really small galaxies. So in terms of making predictions for what we should see with observations, I now define some observable quasar samples. So here I now can consider the effects of dust attenuation. So I define an observable quasar to be one where the AGN is brighter than the host, including the effects of dust attenuation on both the AGN and the host, which is modeled by the simulation. And I define three samples. So we've got SDSS-like quasars, quasars that are currently observable to current observational limits, and quasars that we expect should be observable with W first. And so here we just have some images of the stellar mass distributions of a range of these objects. So we can make predictions for what we expect to see with James Webb using software called SynthObs. And so here we have plots using the in the NearCam F115W filter. So this is the bluest filter, redwood of the Lyman break at redshift 7. So each of the different rows is just a different sample system. And then on the left, we've got, if you just image the host galaxy, if the quasar wasn't in the object at all. The middle panel is just the quasar itself. And on the right, we have the host and the quasar combined. And so what you may be able to see is that these objects, the combined images really just look like the PSF of the quasar, particularly for these two. And so with James Webb, it's still going to be very difficult to distinguish the host emission from the quasar emission. However, we find that the lower the contrast between the quasar and host galaxy, the easier it will be to to detect the host galaxy. And so it's not necessarily looking at the faintest quasars that will be helpful, but the quasar needs to be faint relative to the host galaxy. We can also have a look at what we expect for the what we predict for the black hole stellar mass relation at redshift 7. So here we have the black hole stellar mass relation, again, BlueTides galaxies in blue. The local relationship is given as the black dashed line, which you may be able to see here. And so the redshift 7 relation of BlueTides galaxies is actually reasonably similar to what we see at high redshift. However, it is slightly offset. And so on this plot, you also see these colored points. So these points are, so they're yellow are W first quasars that our predicted W first quasars, orange currently observable, and red are SDSS quasars. And the lines of best fit to the relation for these three samples are given as those colored lines here. And the best fit line for the overall relation is given by the blue. And so what you can see is that the quasar samples are biased to having a high black hole mass for a given stellar mass. And so what this means is if you observe a sample of quasars at high redshift, you will measure a biased black hole stellar mass relation by 0.2 dex. So that's just something that needs to be accounted for when you're actually making these kinds of observations. So with the current capabilities of telescopes, we still can't understand the host galaxies of high redshift quasars. And so we need to use simulations to understand them. And so we look at the properties in terms of galaxy properties and environments of quasar host galaxies. And one thing that we find is particularly different about quasar hosts is that they're generally quite compact. We also note that if you observe quasars at high redshift, you'd observe a biased black hole stellar mass relation to the intrinsic relation. And unfortunately, observing the host galaxies will still be difficult with James Webb. However, with the launch of James Webb and then in the future WFIRST, certainly the possibilities for observing these galaxies will be much more promising. Thanks.